Hello friends, welcome back to our channel Adamya Education. So like yesterday we were doing the 2020 question paper of physics. We are going to finish it off today by completing section 2. So let's waste no more time and begin with question number 5. The figure below shows a simple pendulum of mass 200 gram. It is displaced from the mean position A to the extreme position B. So from the figure also it is quite clear that A is the mean position and B is the extreme position of a pendulum. And also you know one thing, that in case of a pendulum and in case of an object which is falling from the top of any tower or any cliff, the total energy, the total mechanical energy, that means the sum total of the potential and the kinetic energy will be same. Alright, so A is the mean position and B is the extreme position, it has been said. Now what has been said, that point B is at a height of 5 meter from the ground level. So now we have to calculate the potential energy of the pendulum at point B. Now if you remember, it was given in your book in a very clear manner that at the mean position there is no potential energy because it is not lifted above the surface. So the potential energy is 0 and the kinetic energy is equal to mgh, which is actually the potential energy at point B. So at point B the potential energy is mgh, but there is no kinetic energy. And at position A the potential energy is 0 but the kinetic energy is equal to mgh. And as a result, at any position throughout, the total mechanical energy will remain same. Alright, so first of all let us find the potential energy at point B, which can be found out by using the formula mgh. So mgh, our mass is given as 200 gram. We have to convert it into kg because we have to convert it into the SI unit. Hello Vani, welcome to the live stream. So let us find out the value, 200 gram. So 200 by 1000 into, we have to take the value of G as 10, it has been mentioned, into H. H is 5, it has been given. So the answer is 10 joule. So the answer of the first question is 10 joule. This is the potential energy of the pendulum at point B. Okay, let me erase the excess things. Let it be clear. Okay then. Now your second question is, what will be the total mechanical energy at point C? What can we do in English literature? Okay, I guess the best way to cope up with English literature will be to read your textbook very nicely. You should be thorough with the stories and the poems also. And also do one more thing, in your workbook you will have a lot of writing related to the critical appreciation or related to the characters in the story, or what is the author trying to explain by using the various stanzas or the various symbolical words in the poem. You can go through it very nicely because I have also given the board examinations and I have seen my sister giving the board examinations. The questions which are asked are quite direct. The questions are not very tough. Don't expect that they will make a very tough question paper for you guys. The question paper is simple, lucid, and you will be able to answer the questions if you are thorough with the syllabus, with the subject. So that's all what you can do now because there is not much time left. So whatever you have studied, don't start reading new topics right now because it's not gonna help. It's gonna make you confused more and more. So the best thing is, whatever you have studied till now, just go through it once again, revise it nicely, and be confident enough and give the examination. Okay, now the next question is, what is the total mechanical energy at point C? Like I told you, in case of a pendulum, in case of the movement of a simple pendulum, the total mechanical energy is conserved. So as a result, if the potential energy at point B was 10 joule, therefore the total mechanical energy at point C will also be equal to 10 joule. Because at point B there was no kinetic energy. So the total energy, the total mechanical energy was equal to 10 joule only. So at any position which you will consider now, 10 joule will be the total mechanical energy. Welcome Vani, welcome. Okay, let's move on to question number 3 now. What is the speed of the bob at the position A when it is released from B? So just imagine we have held the bob at B position and then we are slowly releasing it. What will happen? It will move to point A, which is the mean position. So we have to find the velocity in that case. So very simple, because we know whenever potential energy is converted to kinetic energy, we can use half mv square is equal to mgh. So we are going to do the same thing. So as soon we are releasing the bob from position B, it is its potential energy, which was in the form of mgh, it is converting into kinetic energy. So potential energy is equal to kinetic energy. That means half mv square is equal to mgh. So m and m gets cancelled out. So your V will be equal to 2gh square root of this, square root of 2gh. So let us find the value. So square root of 2 into g is 10. Our height is 5. So 10 into 10, that means 10 meter per second is the answer. So this is the answer of the third question, 10 meter per second. So make sure that you are writing the units properly, because otherwise half marks will be deducted for each question. So this is the question which we have completed. It was a very easy question, although it looked a little tough because of the diagram, but it was a very simple question. Now let's move on to the next question. It is about centripetal and centrifugal force. Okay. With reference to the direction of action, how does a centripetal force differ from a centrifugal force? The answer is in the name itself. So you know centripetal means center loving and centrifugal means center hating. Okay, so the direction of centripetal force will be towards the center or towards the inner portion. So the answer will be radially inward. You can also write towards the center of the circle, that is also okay. Radially inwards, this is for centripetal force. And centrifugal means it will move, the force will be directed towards the outside of the circle, so it will be radially outwards. We have not been asked difference, we have been asked the difference in terms of the direction. So don't write that centripetal force is a real force, centrifugal force is a fictitious force. That will not give you any marks. Okay. Alright, then let's move on to the next question. Is centrifugal force the force of reaction for centripetal force? Many people think that yes, both centripetal and centrifugal force, since one is directed outside and the other is directed inside, that means they are the reaction forces of each other, like in Newton's third law. But no, it's not true. So you have to just write no or yes. You don't have to explain, but I'm just explaining it to you so that you can remember these things. What happens actually? We know that centripetal force is a force which is directed or which pulls any object moving in a circular orbit towards the center. It is directed like that. But centrifugal force is actually not a real force. It is a fictitious force. It appears to act when the person is observing the uniform circular motion from the center of the circle. Like for example, in a merry-go-round, if a person is standing at the middle of the merry-go-round, he will be able to experience a force. He will be able to assume that a force is being acting. So that assumed force is known as the centrifugal force. It does not exist in real life. And as a result, we cannot say that they are the reaction forces on each other. And moreover, they do not act from the same point. They act at two different points. Although their direction is opposite, but their point of acting is different. The point from which they are originating, that is also different. So they cannot be reaction forces of each other. Alright, I hope it is clear. Now your next question is compare the magnitudes of centripetal and centrifugal force. I told you yesterday also, whenever the word compare is given, that means you have to find the ratio. Okay, so you know that centripetal and centrifugal force are completely equal in magnitude, so their ratio will obviously be 1:1. So this is the answer. Easily you will get 3 marks for such small questions. Just imagine. Getting marks is not at all tough in your board examinations, right? Okay. So I hope this question is clear to you. The number C question is not there in the syllabus. It is from the chapter machines, block and tackle system, which has been removed now. So I have skipped it. Let's move on to another question over here. A diver in water looks obliquely at an object AB in the air. So we have been given the eye of the diver. The diver is in the water and he is observing at an object AB which is present in the air. We know one thing, that when a person is looking at something in the water from air, it appears to be short. So obviously, if the person is in the water now and he is looking at something on the water surface that is in the air, that means it will appear to be taller. Okay, Vani is saying, ma'am, calorimetry kara do. I'm going to bring a video very soon on my channel on the basis of some numericals which are generally asked in calorimetry. And today also in our live session, we have a question related to calorimetry. So don't worry about it. We are going to complete calorimetry. And I hope I'm going to release the video by tomorrow. And after seeing the video, I hope all your doubts will be clear, because I have explained it in a very, very simple manner owing to what difficulties I faced when I was preparing. To be very honest, calorimetry was one such chapter which put me in a lot of tension, because I was never able to understand it completely. So in order to ease that out, I am bringing a video tomorrow. So don't worry. You keep studying whatever you know, whatever you're thorough with, and when that video comes, I hope it will help you out. Alright. So our first question is, does the object appear taller, shorter, or of the same size? Like I told you just now, it will appear taller because the person is observing it from a rarer medium, from a denser medium. If the person would have been observing it from air, then it would have appeared to be shorter. Okay. Now your next question is, you have to complete the ray diagram, and in order to show that how would it appear taller. So I am drawing it using a red color. Hope you understand. So talking about the ray AC, since it is moving into a denser medium, it will bend towards normal. Similarly for AD, it will bend towards the normal. Now I am just going to make dotted lines in order to join them. Although the lines are not very straight, I hope you understand. So this entire red figure, this will be the height of the object which will be perceived by the person inside the water. Okay, so let me name it as A dash. So A dash B will be the size of the object which will be now seen by the person who is inside the water. I hope it is clear. So this is how you can complete the ray diagram. Alright then, let's move on to the next question. Complete the path of ray AB through the glass prism in PQR till it emerges out of the prism. Given the critical angle of glass is 42. So even if this line is not given, you should be able to remember that the critical angle for glass is 42 because it will be required in such questions. So let us do this. Question is very easy, but you have to use a little of your brain in order to understand. So first of all, we see that AB is falling perpendicularly on face QR. So obviously it will move perpendicularly only till it touches the face PR. Okay. Now we will check whether the critical angle criteria is met or not, and then we are going to see whether total internal reflection or normal refraction occurs. So let me make the normal first. Okay, now. So this angle is, this is 30 degree, this is 90 degree. So obviously this angle will be 60 degree, right? This is 90 degree. So using the property of triangle, we can say that this particular angle is 30 degree. Isn't it? Now we have to find the angle of incidence. That angle of incidence has to be compared with the critical value. So the angle of incidence is this particular angle. Let me use a different color. This particular angle is the angle of incidence. How much will it be? It will be 60 degree. Isn't it? Because this entire thing is 90 degree. A part of it is 30 degree. So obviously the unknown part will be 60 degree. So what do we see? That the angle of incidence is more than 42. That means it is greater than the critical angle, and hence total internal reflection will occur. So instead of moving outside, it will move inside. So it will be like this. Okay, in this manner. I hope it is clear. Now we are again going to check what will be the angle of incidence on the face PQ. So again, let me make a normal at this position. Okay, sorry, I made it a little, yeah, it will be like this. Now we have to find the angle of incidence for this particular ray on the face PQ. So let's do it. That means you have to find this particular angle. But before that, tell me what will be the value of this angle. How do we find it out? Let me just name it, make it a little easy for you. This is A, this is B. Okay, B is already given. So let me take it as WX. Okay, consider the quadrilateral QBXW. Okay, this angle is also 60 degree because we know angle of reflection and angle of incidence is same. So if angle of incidence is 60 degree, angle of reflection will also be 60 degree. That means this total angle is 120 degree, right? So we see in this quadrilateral WXBQ, one of the angle is 90 degree, one of the angle is again 90 degree, and one of the angle is 120 degree. So if you use the property of angle sum property of quadrilateral, you know that the sum total of all the angles of a quadrilateral is 360 degree. You will get that the value of angle QWX, that means this particular angle, it will come up to 60 degree, right? And we know that this angle is total 90 degree because it is the normal, although it does not look like 90 degree in my figure, but I hope you understand. So this is 90 degree. As a result, the small angle, that is the angle of incidence on the surface PQ, that will be 30 degree, isn't it? So 30 degree is lower than the critical angle. That means normal refraction will occur, and instead of reflecting back into the same medium, it will pass away in this manner. Okay, so this is your final diagram. So you don't have to make so many angles in your figure. Okay, you can just make it using a pencil for your own understanding, and later after you have completed the diagram you can erase it off, because otherwise it looks very congested and clumsy. Okay, hello Lucifer, welcome to the stream. Hello Mayuk, welcome to the stream. All right, I hope this question is also clear to you. Let's move on to the next question now. Okay, we have to use the lens formula here. Another very interesting question, one of my favorites. So let's do it. A lens of focal length 20 cm forms an inverted image at a distance of 60 cm from the lens. We have to first of all identify the lens, and then subsequent questions have been given. So let's do it. The first thing which we have to do is you have to identify the lens. So in our question only we have been given the hint. The lens forms an inverted image. An inverted image is only formed by a convex lens. So the answer will be convex. Okay. Now we know for a convex lens that the value of f and the value of v is positive because it lies on the right hand side, and the value of u is negative. How do you remember which one is positive and which one is negative? We have to consider the lens to be the origin or O, and whatever is to the right of that lens, that will be positive, and whatever is to the left of the lens, that will be negative. Just like in case of a number line, the same thing you have to follow here also. Okay, so let's do it. Okay, so we have to find how far is the lens present in front of the object. That means you have to find the object distance u. So we don't know the value of u. The value of v is given to us. The image is formed at a distance of 60 cm. So it will be plus 60 because the value of v is on the right hand side. F is given as 20 cm. This will also be positive. So we know from the lens formula that 1 by f is equal to 1 by v minus 1 by u. So 1 by 20 will be equal to 1 by 60 minus 1 by u. So let us solve it. So you can take the LCM as the product of these two. I generally prefer it doing this way. You can also take the LCM as 60. So you are getting minus 40 by 60 into 20, 30. So 1 by u is equal to minus 1 by 30, which gives us u equals to minus 30 centimeter. So like I told you, in case of a convex lens, the value of u lies on the left hand side. So as a result, it is a negative. So minus 30 centimeter is the answer. Minus 30 centimeter. So this is the value of u. Now we have been asked to find the magnification of the image. Let us do it. We know magnification m is equal to v by u. So v was given to us as 60, and we have found the value of u as minus 30. So our answer is minus 2. So this is the magnification. Minus 2 means it is inverted, and 2, that means it is larger than the object. I hope it is clear. Now let's move on to the next question. Over here we have to give reasons for certain phenomena they have asked. It is from the chapter spectrum. Let us do. So during the day, clouds appear white and the sky appears blue. We have to give reasons for the same. The question is of 3 marks, so at least you have to write this much. You just cannot write a single line answer and expect that you will get good marks. Okay, so you have to write a little bit. So why clouds appear to be white? Let us see. The clouds contain dust particles and aggregates of water molecules. Aggregates mean small parts of water molecules. When a water molecule has been broken up into a lot of parts. So these dust particles and these water molecule parts are also bigger as compared to the wavelength of visible light. Whatever components the visible light has, compared to their wavelength, these dust particles and the aggregates of water molecules, they have a larger size. As a result, what happens? These particles can scatter each and every color of the white light to the same extent. Like for example, you know that blue light has a short wavelength, and as a result it is scattered the most, it is scattered the most by the dust particles. But in case of clouds, what happens? The size of the particles present in it, the water molecules or the ice particles, whatever, they have a size which is larger than the wavelength of visible light. As a result, each and every component of white light is scattered to the same extent. And you know, when the scattered light, the white light is scattered to the same extent, it will mix up again to form the original color only. So what was the original color? It was white. So even after scattering, the original color is maintained, as each and every color is scattered to the same extent. Okay, none of them are scattered more or none of them are scattered less. All of them are scattered to the same amount. As a result, clouds appear to be white. Okay. Now our next question is, the sky appears to be blue. As we know, in our spectrum, we have a blue zone and we have a red zone. We are not considering the green because there are no other shades of green, isn't it? So we know one thing, that blue light has a very short wavelength. Blue or violet or indigo, the entire three color range together. So they have a short wavelength, and whenever any light has a short wavelength, they are able to interact with the dust particles much more, and as a result they are scattered more. Let me explain it to you using a diagram. Like for example, these are my dust particles, these red dots are my dust particles. So I have two light, one is red and one is blue. So let me consider blue light first. Blue light has a short wavelength, that means it will look like this, isn't it? So as you see, they are interacting with each and every dust particle. So as a result, they will get scattered. These dust particles will scatter them everywhere. Okay, now if we consider red light, let us consider red light. Okay, and let's see what change occurs. Okay, so these are my dust particles, and now red light is coming. So red light has a long wavelength, so it is not interacting with any dust particle only. So how will it get scattered? So this is the reason. Okay, I don't think this is given in any of the books. So this actually happens. Scattering occurs whenever the dust particles are interacting with the light. But in case of blue light has such a short wavelength that it will interact with almost each and every dust particle, and hence it is scattered so much that the entire sky looks as if it is blue in color. I hope this is also clear. Very interesting phenomena. Okay, let's move on to the next question now. Name the system which enables us to locate underwater objects by transmitting ultrasonic waves and detecting the reflecting impulse. So whenever we want to study about things which are underwater, like the fishes or the wrecked ships or the depth of an ocean, we use the system called sonar, sound navigation and ranging. You know about this already. It is based on the principle of echo. So this is the answer. Now your next question is, what are the acoustically measurable quantities related to pitch and loudness? You must have studied about the three characteristics of sound, that is pitch, loudness and quality or timbre. And these are all subjective quantities. That means it can vary from person to person. Like for example, a sound which might not seem to be loud enough for the new generation can be irritating and can be loud enough for the people who are a little old, right? So these change from person to person, so they are called subjective quantities. So in our question, we have to say the measurable or the objective quantities related to these characteristics. Pitch. For pitch, the measurable quantity is frequency. There is a table given in your book. And for loudness, the measurable quantity is amplitude. So frequency affects pitch and amplitude affects loudness. So amplitude and frequency can be measured, isn't it? For me, if the amplitude is 20 meter, for the other person also it will be 20 meter only. But loudness may vary from person to person. Okay, so this is the answer. You have to understand the question. The question itself looks complicated, right? Words like acoustically, measurable quantities, people will leave the question thinking that what the hell is this? But no, it's a very simple one. Okay, then let's move on to the next question. I have written the answer already. I'll explain it to you. When a tuning fork, which is vibrating, is held close to our ear, we hear a faint hum. A very faint sound is heard. But when the same tuning fork is held such that its stem is in contact with the table surface, now if you place the vibrating tuning fork on a table, you will hear a loud sound. So we have done this while we were doing our graduation. We have seen this happening in front of our eyes. So why does this happen? You know one thing, that sound requires a material medium for propagation, right? And more the amount of medium, more will be the sound, right? More the area of the medium. So what happens when the vibrating tuning fork is brought close to our ear? A very small amount of air is present nearby it, so the sound which is transmitted to our ears, it is very faint, it is very small. But when the same tuning fork is placed near a large table, the table has a large surface area, so the sound will have a very large surface, or a very large you can say the sound will have a very large volume of air to transmit. As a result, a loud sound is heard. So the main reason is that presence of a large amount of air in case of a table. Okay, and whenever we are using the same tuning fork on a table, the vibrations are in the form of forced vibrations, because we are forcefully making it happen, right? It was the air on the table or around the table was already not in vibration, but because of our action, the air is set into vibration, and moreover the space is so huge that the sound gets a large space to transmit itself, and as a result the sound we hear is quite large. So this is the answer of your question. So I hope it is clear to you. This is also from the chapter sound itself. Now the next question is related to a numerical. After this we will take a small break of 2 minutes, and then we will move on to the rest few questions. So let us quickly complete this. Okay. A man standing in front of a vertical cliff fires a gun. So let us quickly make the cliff and the man. This is the cliff and this is the man. Okay. So he's standing in front of a vertical cliff and he hears the echo after 3.5 seconds. So let us consider that initially he was standing at a distance of x. Okay. So for x distance, we know velocity is equal to 2 into distance by time, 2d, because the sound is going and coming back, echo. So we are multiplying 2 with the distance. So it will be 2x by the time was 3.5 seconds. Okay. Now what happens on moving closer to the cliff by 84 meter? Now he is moving closer to the peak. So this much is 84. So what will be the value of his distance from the cliff? Initially it was x, now it is x minus 84. So this is the new distance, right? So now for this distance, let us see what will be the relation. So for x minus 84, so your velocity will be 2 into x minus 84 by the time after which he hears the echo is 3. So in both the cases, we see that the velocity of sound is remaining same because the person is standing in the same medium, right? So we can equate these two equations. So it will be 2x by 3.5 is equal to 2 into x minus 84 by 3. So from here, if we find out the value of x, that will be the answer, because our question is we have to find the distance of the cliff from the initial position of the man. That means we have to find the value of x. So let us solve this question. So a very direct question which has been asked based on two different positions but in the same medium. So if we solve it, let us see. 2 and 2 gets cancelled out. So 3x is equal to 3.5x minus 294. So you are getting 294 is equal to 0.5x. As a result, the value of x is 588 meter. So this is the answer. I hope it is clear to you. Very easy question. Okay, then let us take a small break of 2 minutes, drink some water, get refreshed because we have done a lot of questions, and then we are going to get back to question number 8. So welcome back, guys. Let us finish the few questions which are left, and then 2020 physics question paper will also be completed. Okay then. So our question is, what are superconductors? Okay, before we do this question, let me just give you a small idea about it. Superconductors are based on resistance, zero resistance, and this type of resistance occurs at a very low temperature. So although it is not completely feasible at present, it is not completely possible now, but still works and experiments are done in order to make it a possible thing, so that hello Omkar, welcome to the stream. So after a few years, if you see that the size of computers has been reduced to the size of a microchip, you'll be able to remember that yes, years ago we have studied about supercomputers in physics. That will be the reason why those computers could be shrinked into a very small size. So this is still an ongoing process. It will take time to make it a complete success. Okay. So what are superconductors? A superconductor is actually a substance which has zero resistance but at a very low temperature, which is practically very difficult to achieve. So I have also given an example. You have not been asked to give an example, but you can add it. Okay, it won't decrease your marks anyway. So an example is mercury below a temperature of 4.2 Kelvin. This can be an example of a superconductor. Okay. So now your next question is a numerical from the chapter electricity. So you have to calculate the current drawn by an appliance rated 110 watt and 2020 volt when it is connected across the 220 volt supply. A very easy direct question. So you know one thing, P is equal to VI. So we have been given the value of P, which is 110 watt, and the value of V is also given to you, voltage, it is 220 volts. So you have to find the value of I. So I will be equal to P by V. So 110 divided by 220. So 1 by 2, that means 0.5 ampere. So this is the answer. So I hope this question is clear. Very direct question. Okay, your next question is, name a substance whose resistance decreases with the increase in temperature. The answer will be semiconductors. I'm not able to write here. Wait, let me write it below. So the answer in this case will be semiconductors. Semiconductors is a substance which has a very special sort of conductivity. As you are increasing the temperature, its resistance decreases, and as a result it can conduct. So the answer will be semiconductor. You will study more about this in class 12. Okay. Alright. Let's move on to the next question. Over here we have another numerical which is from the chapter electricity. Let's see. So the diagram above shows three resistors connected across a cell of EMF 1.8 volt and internal resistance R. Okay, we have been given a battery whose voltage is mentioned as 1.8 volts, whose EMF is 1.8 volts, and which has an internal resistance of small r. And we have three resistors, this and this. Okay, we have to find the current through the 3 ohm. This will be ohm, not watt. Ohm. We have to find the current through the 3 ohm resistor, and we also have to find the value of the internal resistance. So let us do it. So you know one thing, that in case of parallel combination, the current is different in the different resistances, but the voltage of each and every resistance, or you can say the potential difference across each and every resistance, is same. But in case of a series combination, the potential difference across each resistance is different, but the current throughout is same. That is what we are going to use here. So listen very carefully. So if you consider this entire combination as a single unit, let me consider this as R, and this is another resistance. So the current through the entire of R will be 0.3 ampere, and the current through 4 ohm resistance will also be 0.3 ampere, isn't it? Because if you consider R as a unit and you are considering 4 ohm, they are total in series with one another. Okay, so this is the first concept which we will use. Now let us find the value of this combination in order to find the potential difference across this particular combination. So you have 3 ohm and 1.4 ohm, they are present in parallel to one another. So the equivalent resistance can be found out by using the formula like this, plus 1 by 1.5. So if you calculate it, you will get the value of Rp as 1 ohm. So this entire parallel combination together has an equivalent resistance of 1 ohm. That means 0.3 ampere is passing through this 1 ohm and through the 4 ohm also, and also through this internal resistance small r. Now, since 1 ohm and 4 ohm are in series, that means the potential difference across them will be different. It will not be same. So we will find the potential difference across the parallel combination, across this combination. Okay, so let's do it. Let me erase this part. Okay, so I have the current as 0.3 ampere. I have the total resistance only for the parallel combination. Okay, don't consider the entire circuit. It is 1 ohm. So how can I find V? V equals to IR. So it will be 0.3 volts. That means if you consider 2 points A and B, over here this is A, this is B, these 2 points across the parallel combination, they will have a potential difference of 0.3 volt. Okay, now the potential difference for a parallel combination is same. That means for the 3 ohm the potential difference is 0.3 volt. Similarly for the 1.5 ohm resistance, the potential difference will be 0.3 volt. Yes, I hope this is clear to you. Now how do we find the current through the 3 ohm resistor? Now the resistance is 3 ohm. The potential difference is 0.3 volts. So what will be the current? We know from Ohm's law, V equals to IR. So I will be equal to V by R. That means 0.3 divided by 3, which gives you 0.1 ampere. So this is the answer. So you could have done it simply by using a formula which is given in your book most probably, but I don't prefer using it personally because you have to memorize. And what's the use of studying when you have to memorize things, when you have to mug up? So understand it and then do, because these small things are going to be used in a lot of derivations in the later stages of your life if you take up science. So make sure that you're understanding things, understanding the concepts instead of memorizing. So we have found out the current. It is 0.1 ampere. Now your next question is you have to find the internal resistance small r. This is a very easy one. Let's do it. In order to do this, let us first find the total resistance through the circuit. We know V equals to IR. So R will be equal to V by I. What is the total EMF of the device? It is 1.8 and the current is 0.3. So the resistance of the entire circuit is 6 ohm. Okay, now this 1 ohm, this 4 ohm and this small r is in series. That means we can say that 1 ohm plus 4 ohm plus the internal resistance is equal to 6, because 6 was the total resistance. So what will be the value of R? 6 minus 5. That means 1 ohm. So 1 ohm is the answer of the second question. The second question was very direct. The first question you had to do a certain number of steps in order to arrive at the answer. I hope this question is also clear. Very simple one, but you have to understand it nicely. Alright, let's move on to the next question. Define the heat capacity of a substance. And we have to write its SI unit also. Okay, let's see. So what is the heat capacity? The heat capacity of a body is the amount of heat energy required to raise its temperature by 1 degree Celsius or 1 Kelvin. So this is a direct definition based question which is given in your book. So this is the definition of heat capacity. It is actually the amount of heat energy that you have to input into a system in order to raise its temperature by a value of 1 degree Celsius or 1 Kelvin. Now you may ask that why 1 degree Celsius and 1 Kelvin has been taken. Celsius and Kelvin are not equal, they have a different relation. But you know that there are 100 divisions in a Celsius scale. Similarly, there are 100 divisions in a Kelvin scale. So the difference between any two values on the Celsius scale and any two values on the Kelvin scale, that difference is equal. So you are just raising the temperature by a particular value. Right, so you can consider either Celsius, either Kelvin. It's not an issue. Okay, so now what is the SI unit? The SI unit is joule per Kelvin. Amount of energy divided by the amount of temperature rise. So joule per Kelvin is the answer. Okay. Your next question is what is the relationship between heat capacity and specific heat capacity of a substance? Very easy question. For this you should be thorough with the formula for specific heat capacity and heat capacity. So the specific heat capacity is denoted by C and the heat capacity is denoted by C dash. So C dash is equal to energy divided by the difference in temperature, so Q by del T, and specific heat capacity is the heat energy divided by mass into difference in temperature. Because if you remember the definition, it has been said that to increase the unit mass of a substance by a temperature of to increase the temperature of unit mass of a substance by 1 degree Celsius or 1 degree Kelvin. So you have to consider this mass also. So what do we see here, that in both the cases we have Q. So if you are keeping Q on one side and you are taking all the other quantities to the other side, you are getting Cm del T is equal to Q. Over here we are getting C dash del T is equal to Q. Right? In both the cases, Q can be equated now. So we are having C into M into delta T is equal to C dash into delta T. So delta T and delta T is getting cancelled out. So you are left with C dash is equal to C into M. That means the heat capacity is equal to the mass into the specific heat capacity. This is the relation. Write it in words also. I am just writing it in the mathematical expression, but make sure you are writing it in words. Okay, so I hope this question is also clear. A very direct and simple question. Okay, then let's move on to the next question. So over here you have a heating curve of, it has not been mentioned of which substance, it can be any substance. Okay. The diagram below shows the change of phases of a substance on a temperature versus time graph on heating the substance at a constant rate. Okay, so in the x-axis you have the time and on the y-axis you have the temperature. So you have been explained the change of phase from A point to point F. Okay. So what is the first question? Why is the slope of CD less than the slope of AB? So let us consider the values, let us consider the slope of CD. It is very much clear from the figure that CD has a smaller slope as compared to AB. So let us see what is the answer. In the part CD, as you can see that the rate of rise in temperature is slow as the substance in this phase has high specific heat capacity. So what we are considering here, we are considering the increase in temperature with respect to time. So as you can see that the slope of CD is a little smaller as compared to AB. That means the temperature change in the phase CD is occurring quite slowly compared to AB. In AB, the temperature change is occurring very fast. As a result, it is steeper as compared to CD. So in the phase CD, the temperature change requires a little more time compared to the temperature change in AB. As a result, you can say that the slope is different, and this difference in slope is actually attributed to the value of their high specific heat capacity. Because of high specific heat capacity, you can see that in the phase when the substance is melting and in the phase when the substance is going to boil, there is a difference in the amount of time required to raise the temperature. Clear from the figure now and from the explanation that the substance we are talking about is water, because water has a very high specific heat capacity, isn't it? So you have to say that in the phase CD, the temperature change is time consuming as compared to the phase AB. As a result, the slope of CD is lower than AB. I hope it is clear. Now your next question is, what is the boiling and the melting point of the substance? So boiling point is the point where the substance starts boiling, and melting point where it will melt from its solid state. So from the figure, it is very clear that T2 is the boiling point and T1 is the melting point, because from A to B this object is melting, or you can say the object is increasing its temperature slowly and it is reaching its freezing point or melting point. So your melting point will be T1 and your boiling point will be T2. Don't write D and B, those are the points on the graph, but you have been asked about the boiling and the melting point. So the melting point is T1 and the boiling point is T2. Hope this question is also clear to you. This is a very important question, but it can easily give you 3 marks. Okay, let's move on to another question. Like I told, we have a question related to calorimetry over here. Let us solve this question. Principle of mixtures. Okay. So a piece of ice of mass 60 gram is dropped into 140 gram of water at 50 degrees Celsius. Calculate the final temperature of water when all the ice has melted. Okay. So whenever such questions are there, when you are mixing ice with water or you are mixing two liquids, you have to remember one thing, that the amount of heat which is lost is equal to the amount of heat gained. This is the principle of calorimetry, as you all know. Also, one more thing, that heat is always lost by the object or by the body which is at a higher temperature, and heat is gained by the object which is at a lower temperature. For example, if you place two cups, in one cup you have ice cold water and in the other cup you have tea, and you are placing it in close contact with each other, what do you observe? After some time, both of them will almost reach the same temperature. So what has happened? The cold object or the ice cold water is increasing its temperature, and the tea or the cup in which the hot beverage was kept, that is decreasing its temperature. So heat is always lost by the object which is at a higher temperature, and heat is gained by the object which is at a lower temperature. I hope this is clear. We are going to use the same over here. Okay. So heat lost by water, the water which was at a temperature of 50 degrees Celsius, it is losing heat. So before that, let us do one thing. We have to find the final temperature. So let the final temperature be T. Okay. So heat lost by water first. Make it like this, step by step. It will be easy for you to understand and also for the examiner. Heat lost by water. So water was at 50 degrees Celsius. So water at 50 degrees Celsius is converting to water at T degrees Celsius. So the final temperature is T. So the temperature of water will get reduced to T. So water at 50 degrees Celsius to water at T degrees Celsius. So heat lost will be equal to Q equals to MC delta T. Since there is a difference in temperature, this is our formula for by using specific heat capacity. So our mass of water was 140 gram. So 140 into the value of C for water is 4.2, and delta T, that means difference in these two temperatures. Which one will be larger? Obviously this, it is losing heat and it is becoming T degrees Celsius. So 50 degrees Celsius is the larger value. So 50 minus T. Okay, so why didn't I convert this gram into kg? Because see, in the values which have been provided, we have gram. So why to convert? Let us keep it as it is. If it was given in kg, then we had to convert. Okay, so you are going to get, let's just leave it like this. We can do it while calculation. Now heat gained by ice. So ice will not directly change into water at T degrees Celsius. It has two steps going on. We will see what it is. So heat gained by ice. Okay. So ice was initially at 0 degrees Celsius. It will first convert to water at 0 degrees Celsius. Without changing its temperature, it will just change its phase. Okay, so whenever change in temperature does not occur but change in phase occurs, we will use the latent heat formula. So our energy will be ml. The mass of ice was given to us as 60 gram. Okay, so 60 into 336. So 20160 joule. Now this water at 0 degrees Celsius will have to convert to water at T degrees Celsius because that is our final temperature. So let us do it. I am erasing this part. So sorry, water at 0 degrees Celsius to water at T degrees Celsius. So in this case, which is greater? Obviously T degrees Celsius is greater because what the ice which has now converted into water, that will increase in, that will take heat, that will gain heat. So its temperature will obviously rise. So T degrees Celsius is larger than 0 degrees Celsius. So what will be Q? You see that there is a difference in temperature. So we have to use the formula MC delta T. Whenever you see that there is a difference in temperature, MC delta T, and whenever there is no change in temperature, so ML. So mass was 60 gram because this is the ice which has melted, right? So don't take 140 gram into 4.2 into del T, that means T minus 0. So 252 T. Okay. So according to the principle of calorimetry, we know that heat lost is equal to heat gained. So your heat was lost by water, we found out as 588. We can multiply it, 588 into 50 minus T is equal to the heat was gained. This is one heat gained and this is the other heat gained. So we can write it like this, 20160 plus 252 T. So if you solve it by using linear equation, the final value of T comes up to 11 degrees Celsius. So this is T, the final temperature. So I hope this question is clear. This question had a marks of 4. So very, very important question. So whenever two objects are mixing, you have to follow this type of procedure, this type of approach. Hope it is clear to you. Let us move on to the next question. It is from the chapter radioactivity. Let us see. Okay. Differentiate between nuclear fusion and nuclear fission. There is a table given in your book. I have used two differences over here. Okay, so you can write as many differences as you want depending upon the marks. So the first and the easiest difference is that fission is actually the splitting of a larger atom into two or more smaller ones. Actually the nuclei is splitting. So fission is the splitting of a nuclei into two or more smaller nuclei, but fusion, as the name suggests, it is actually the combination of smaller nuclei to form a larger one. Okay, so this is the difference. And fission can occur at room temperature. If you keep a radioactive substance as it is, it will start emitting the various types of radiation. But fusion requires a very high amount of temperature which has to be provided externally. Okay, so these are the two differences. The question was of 1.5 marks each, so you have to write two differences. Your next question is state one safety precaution in the disposal of nuclear waste. It has been given in your book. Let me just read it out for you. Nuclear waste should be disposed of in thick lead casks. Why lead? Because lead does not allow the radiations to pass outside it. And then it should be buried deep inside the underground mines. There are special mines which are made specifically for the radioactive materials, radioactive waste. So only in those mines the radioactive waste should be disposed of. And also it should be away from the localities. Otherwise, by any chance, if the radioactive material seeps out, then it can be a huge detriment. Then it can cause a huge detrimental effect. Okay, hope this question is clear. Now the last question is we have been given about certain changes occurring in an atomic nucleus. Okay, let's do it. So an atomic nucleus A is composed of 84 protons. So the proton number is 84 and the neutron number is 128. So the mass number, if you add it up, because we know mass number is equal to number of protons plus number of neutrons, so the mass number will become 212. So your first question is, the nucleus A emits an alpha particle and is transformed to nucleus B. What is the composition of B? Let's see. So this nucleus, okay, we cannot take it as A because A has already been given here. So let me take it as small a rather. So this is the mass number. So A had a mass number 212 and an atomic number 84. So it is emitting an alpha particle and it is becoming B. So B will be 208 because the mass number is decreasing by 4. So 212 becomes 208 and 84 becomes 82. 82. So 82 because the atomic number is decreasing by 2. So the nucleus B will be written like this. B, 208 is its mass number and its atomic number is 82. Alright. Now your question is find the composition of B. Composition means you have to write the proton number and the neutron number. You cannot leave it like this. So the proton number is 82 and the neutron number will be the mass number, that is 208 minus the proton number, that is 82. So your answer is 126. So this is the composition of B. Composition means you have to write specifically about the internuclear particles. Okay. Next question is the nucleus B now emits a beta particle. Okay, let me erase this thing. So number 2, B was 208, 82. Now this emits a beta particle. So what will happen? It is becoming C now. Okay, C. So the atomic number is increasing by 1. So 82 becomes 83 and the mass number remains same. So 208 remains 208. So what is the composition? The proton number is 83, but the neutron number will be equal to 208 minus 83, which will give you 125. So the answer is 125 in this case. Hope it is clear. Okay, now your next question is, does the composition of C, okay, what is the mass number of nucleus A? We found out the mass number, it was 212. So the answer is 212. We already found out initially. And your last question is, does the composition of C change if it emits gamma radiation? No, whenever gamma radiations are emitted, no change occurs in the composition. So everything remains as it is. So this was the question. It consisted of 4 marks. It looked a little confusing, but it was not. You just had to break the mass number into neutron number and proton number, and that's all. Hope the paper is clear to you and hope you have been able to understand whatever I have taught in the class. Next day we are going to do biology question paper of 2019, because I guess you all know that in 2020 the examination could not be held due to the pandemic. So we are going to do 2019 question paper for biology. Till then, if you have any doubt, if you have any sort of difficulty, you can send me your doubts, your questions in the email which has been provided in the description box. And we are going to meet very soon, most probably tomorrow, for the biology live session. Till then, keep studying because your exam is very close now. So work hard and all the best once again. And thank you everybody for listening to me patiently. Bye bye everybody.